So my code first starts out with defining all my variables, then it goes into setup and it starts the serial begin, so it starts the serial, then I set my potentiometer to an input value, then in my void loop, I start the timer. This is a precise one. I decided to use millis instead of micros as micros didn't work, and then I find my value, read my value from the potentiometer, and I added a 1 to prevent it from hitting 0, and then I did my calculation to find delta T. And then I read my value from my end scope using analog read 3, and then I printed that to allow it to communicate with processing. And then the while loop at the bottom allows for the timer to happen while the time is less than delta T. Here are my screenshots from step number 3, and every image that is highlighted in yellow experiences aliasing. Nyquist frequency equals fs divided by 2, and the Nyquist frequency is the max frequency in the sampled signal. If the max frequency is greater than the Nyquist frequency, it will be aliased. It should also be noted that on the voltage and frequency graph, there's one signal at around 2.5 hertz, and that's the fundamental frequency, and then the others at the frequency wanted, which are other harmonics. Here are my calculations for step 6 from the table, and how I did the folding diagram is I determined which side it would be on, and then I either went forward or backwards based off of that. Here is my table from step 6, and anything highlighted in pink are aliased, and most of my theoretical and experimental values were fairly close to each other, which was good. And to calculate the Nyquist rate, it was 2 times f, and in the last video you just saw how I calculated my alias theoretical values. This is my setup for the first part of the lab, with the potentiometer being connected first to ground, then to analog pin 4, and then to power, and then I have it connected to channel 1, and then A1 also connected to A3 on there. And then for the second part where you need a square wave, I'm just going to move it to the pulse 1. Now starting exercise 2, this is my triangle wave, and I'm about to start the processing code, and this is using the same format we had from exercise 1, and so I'm putting port 6, which is what I have, and now you can see the triangular waves popping up. Now this is the square wave, and I'm also going to start the processing code now. I'm going to enter in port 6. And as you can see, now the data is going to propagate as a square wave. It is very clearly shown in the square waves that for the amplitude spectrum plot, that not all values are at 1, meaning that it has a bunch of harmonics.